Hey guys, I hope everybody had a good one. I'm so sorry I'm not there with you guys today, but I really look forward to seeing you guys next class. For now, I hope everybody got a copy of the note packet. We're going to start with chapter 2, 2.1, no more trig. And, this is a little bit of a change of pace for us. Okay, so let's just dive right in. So, we're going to start again with section 2.1, but I've split it up, like I have for previous sections. And in doing so, I've had to modify for homework as well. So you're going to have a handout for homework today. I know you guys like those handouts. So here we go. Okay. Right. So we're going to talk about functions, polynomial functions. And we're going to start with talking about zeros of polynomial functions. But before we start talking about zeros of polynomial functions, let's remind ourselves what this mouthful polynomial functions term means. A polynomial function is a function that has variables like x raised to exponents, but the exponents have to be whole numbers, meaning either 0, 1, 2, 3, and so on. So for example, y equals x squared plus x plus 5. That is a polynomial function. You've got variables raised to exponents. And what are the exponents here? You've got an exponent of 2. You've got an exponent of 1. And here you've got a constant term with no exponent. Well, what about that, right? What about that? Where did that come from? Well, before, that used to be x to the power of 0. Well, what's anything to the power of 0? It's 1. So x to the power of 0 is 1, and I can just get away with writing it as 5, right? So another example of a polynomial is y equals x to the 7 minus 5x to the 6 plus 3x to the 4 minus 2x squared plus x. That is a polynomial function. Variables raised to exponents, and all the exponents are either 0 or another integer. Okay, positive integer. Okay. That much for that. Now let's talk about a couple of something completely different. We're going to talk about what we call synthetic division. Okay, so synthetic, is anything that is man-made, right? I don't want to use the word fake, but basically anything that's not the real deal, right? That's synthetic. And so synthetic division is dividing polynomials, but, sort of in the shortcut method, right? So synthetic division is a shortcut used to divide polynomials. The thing with synthetic division is it is used only in the special case of dividing by a linear factor. It means if you've got, some polynomial and you're dividing it by something, the thing by which you're dividing by has to be linear. What is linear? Something like this. Let's start like x minus 5, right? X to the power of 1 minus 5. It has to be linear. So you can divide by x minus 5. You can divide by 2x plus 3. You can divide by x minus 2, and so on. Okay? All right. Let's look at some examples and see when exactly we can and cannot use synthetic division, right? So let's look at this one. I have a polynomial. It doesn't matter. I really can ignore anything in the top. Okay, that can be anything it wants to be as long as it's a polynomial function. It can have any exponent. But let's look at the thing that it's being divided by, right? So you have this thing at the top divided by this. Now this in the blue here can have only x raised to the power of 1. Anything higher and we can't do it. So this, because it has an exponent of 2, synthetic division cannot be used for this. Okay? Now look at this one. You have a polynomial function on top divided by x plus 5. This is x to the power of 1. Yep, this is a fantastic candidate for synthetic division. Look at this. We have a polynomial function divided by x squared plus 1. Nope, that square, it doesn't work. Here we have a polynomial function. I'm not even looking at what that first polynomial function says. But here I have 3x minus 2. It doesn't matter that there is a 3 in front of the x. All that matters is that it's x to the power of 1. Yep, I can do this. Okay, I can divide by synthetic division. Now, we're only going to talk about synthetic division. We're not even going to talk about the other, the real polynomial division, because honestly, it doesn't suit our purposes at all, okay? That is not our focus. All right, let's talk about synthetic division. So here we go. We're going to use synthetic division to divide x cubed minus 3x squared minus 2x plus 4 by x plus 1. So this is actually kind of fun, all right? Okay, so let's do this. So the first thing you're going to do is you're going to set up the synthetic division. And basically what that is this half of a rectangle here, right? So you're going to set up that little space. Okay, next, you want to check to make sure that in this polynomial, all the exponents are lined up in decreasing order, right? And all the exponents are present starting with the biggest one. So here's how we do it. What is the largest exponent here? It's the 3. So now I say, okay, I'm going to count down from 3, and I'm going to make sure that all the exponents counting down from 3 are present in this polynomial. So I have an exponent of 3, 2, 1, 0, I'm all good. Okay? And they have to be in decreasing order. Now, what I need to do now to set up my synthetic division is in here, in the space inside this box, I put all of the coefficients of that polynomial. All right, so what are the coefficients here? Here it's x cubed. There is a coefficient of 1, so I put a 1 here. Next, I have a coefficient of -3, so I put a -3 here. Next, I have a coefficient of -2, that goes here. Coefficient of 4, that goes there. All right, so again, 1, 3, -2, 4. Okay, what goes outside? What goes outside? I take this, x plus 1, set it equal to 0, x is -1, that -1 comes out there. So all this is in step 1 of setting up the synthetic division. Okay, so now I'm set up. Now I can go into the second step. Bring down the leading coefficient to the bottom row. So basically that first one comes down here for free. That's the bottom row, right underneath that horizontal line. Next, multiply the value just written on the bottom row by the outside number. So I'm going to multiply 1 by -1, and that's going to be -1. Now, the next step is add the column created in step 3. So I'm going to add this way. -3 plus -1 is -4. And then I basically repeat until done. So basically, anything that makes its way to the bottom row here gets multiplied by the outside number of -1. So -4 times -1 is +1. And then once I write it over there, I need to add these two, and that becomes -1. Okay, another number made its way down here. Multiply by -1, and I get +1. If it makes its way up there, then I have to add 4 plus 1 is 5. And we're done with our synthetic division, right? So I write these arrows this way on purpose. Why my diagonal arrows stand for multiplication or times, and then my vertical arrows stand for pluses, okay? Now we're done. The next step is to write out the answer. Okay, now here is how we write out the answer. Whenever you divide something, okay, chances are you're going to get a remainder, right? Remember long division when you would get a remainder? Okay, in synthetic division, this last number is the remainder. If all this seems a little bit foreign to you, don't worry, just stick with it. Don't panic. We're going to practice with this a whole lot. Remember, you guys were able to understand and do all of that trig stuff. So we're going to do this too. Okay, so just let's stick with it. So that last number is the remainder. Now, these here, guess what these are called? Those give you what we call, you ready? The depressed polynomial. I know. It has nothing to do with its mood, however, right? That's just what it's called. Okay, so here's how we're going to write this depressed polynomial. Okay, go back to the original polynomial. What was the highest exponent? It was a 3. Well, whenever something goes through the process of synthetic division, the exponent is always decreased by 1. So if the highest exponent there was a 3, now in the new polynomial, the highest exponent is going to be a 2. Okay? These numbers here, 1, -4, and -1, are the coefficients of this new polynomial. So if my new polynomial is going to have a highest exponent of 2, then the way it's going to look is I'm going to have x to the 2, and then I count down x to the 1, and then x to the 0, which is just nothing. So now my answer is 1x squared from here, which is x squared, minus 4x minus 1, right? So it's just these coefficients, plus the remainder 5 over this here, x plus 1. So that is my answer. Okay, let's do another one. Okay, let's do another one. Look at this one. It says use synthetic division to divide this polynomial by x plus 3. Okay, first step is set up the synthetic division. So let's set that up. We're going to look at all the exponents and see if they're in the right order and if all of them are present. Highest exponent is a 4. 3. Oh my God, I'm missing a 2. Okay, but then I have 4, 3, missing a 2, 1, 0. So since the 2, the x squared term is missing, we have to insert a 0 in its place. So here's how that's going to work. The first coefficient is a 1. That goes here. Then I have a 4. Then the x squared is missing. I put a 0. Then -12. Then -9. So let's take a count and see if they're all there. Go into your synthetic division chart. This was supposed to be x to the 4, 3, 2, 1, 0. Oh my gosh, they're all there. We're good. We're ready to go. Okay, what's going to be that outside number? X plus 3 equal to 0. X is -3. Okay, let's do this. The 1 comes down for free. Anything that makes it below this line gets multiplied by the outside number. 1 times -3, -3. I add 1. Multiply by the outside number. 1 times -3, negative 3. Add negative 3. Multiplied by the outside number, 9. Add negative 3. Multiply by the outside number, 9. Add 0. Oh my God, I have a remainder of 0. Perfect. Okay? We'll talk later about what that means. So now, how do I write this function? Initially, my highest exponent was a 4. That's going to go down by 1. So now, instead of x to the 4, I have x to the 3, x to the 2, x to the 1, and nothing. So my answer is going to be x cubed plus x squared minus 3x minus 3. There is a remainder of 0, so this is it. Okay. Let's do another one. We're going to use synthetic division to divide this polynomial by 2x minus 3. Okay, here we have an issue. If there is a coefficient in front of the x here, right, like this 2, you have to divide both polynomials by 2. That means you have to divide this by 2, and you have to divide this by 2. Okay, so now let's write out the divided form here. 2x cubed over 2 is x cubed. Minus 3 over 2, let's just leave it as 3 over 2, x squared, minus 2 over 2x is 1x, plus 3 over 2, divided by x minus 3 over 2. Okay, let's set this up. Are all my exponents there? X to the 3, 2, 1, 0. Yep. So I put 1, negative 3 over 2. It's okay that it's a fraction. Okay, here, what's the coefficient? It's negative 1 times x, so it's negative 1, and 3 over 2. What goes out here? X minus 3 over 2 equal to 0. X equals 3 over 2. Okay, 1 comes down. Multiply by 3 over 2. 1 times 3 over 2 is 3 over 2. Now, negative 3 over 2 plus 3 over 2, hey, that's 0. Multiply, you get 0. Negative 1 plus 0 is negative 1. Multiply, you get negative 3 over 2. So 3 over 2 minus 3 over 2 is 0. No remainder again. Okay, how are we going to write this polynomial now? My highest exponent before was a 3. It goes down by 1. Now it's a 2. So 1x squared, 0x to the 1, and then nothing. So my polynomial is going to be 1x squared plus 0x minus 1. Well, what's 0x? You can just eliminate it, right? So that's just x squared minus 1. That's it. Okay, so let's talk about what a 0 is in algebra, right? In algebra, if we talk about a 0 of a polynomial function, it's the x value where the graph crosses the x-axis. So for example, if I have a function like this, okay, the zeros of this function are all the points where it crosses the x-axis. So there are 3 places where this crosses the x-axis. That means there are 3 zeros. What are the zeros of this function? They are x equals -4, x equals 1, x equals 3. Now, a zero can also be referred to as a solution, an x-intercept, or a root. All four of these words mean the same. Okay, so zero, solution, x-intercept, root. Okay, one thing I want to pause and call your attention to is this. At each of these points where the graph crosses the x-axis, right, what is the y value? So when x is equal to 1 here, what is the y value? Y is 0. At x equals 3, what is the y value? Y is 0. At x equals 4, what is the y value? Y is 0. Because at these points, the value of the function y is 0, they're called the zeros of the function. That's where the function is 0. Okay? Okay. Now, evaluating a function at a given point. Okay, there are two methods to find the value of a function at a given point. These are direct substitution and synthetic substitution. Okay, let's talk about direct substitution. You've probably seen this first. You've probably seen this before. Okay, given f of x is this function, find the desired values. So I need to find f of 2, right? F of 2. If I need to do direct substitution on this and find f of 2, I need to insert 2 for every single x. So this is going to be 2 times x squared. Well, now x is 2, so 2 squared plus 9 times x, 2, minus 35. Okay, so that's direct substitution. You put this number in each of the x's. So now I have 2 times 2 squared is 4, plus 9 times 2 is 18, minus 35, 8 plus 18 minus 35, right? And for these, if you do want to use your calculator, you can. Okay, just be careful. Sometimes all it is just a little, wrong calculator keystroke, and then the whole thing just comes out wrong. So this is going to be -9. So I say f of 2 is equal to -9. Okay? Now I need f of -7. So I'm going to say 2 times -7 squared. Now when the number is a negative, right, f of a negative number, please use parentheses. 9 times -7 minus 35. Okay? So in this case, this is 2 times 49 plus 9 times -7, so it's -63 minus 35. So again, if you want to use your calculator on this one, you're more than welcome to do that. And so here, we're going to get that f of -7, well, let's see here. 2 times 49 is 98. Okay, so here, -63, -35 is -98. Oh my God, f of -7 is 0. Okay? Okay. Now it says, are any of these zeros of the function? Okay, well, here when we plugged in 2, we got -9. But when we plugged in -7, we got 0. Hey, what does that mean? That means this function at -7 crosses the x-axis. Okay? So it crosses the x-axis here. So that means x equals -7 is a zero of the function. Okay, so that, and we knew that because we got 0 here. Okay, now we're going to use synthetic substitution. This method uses the concept of synthetic division to evaluate a function. So look, we've got the same function. We need to find the same points. Okay, yes, we're going to get the same answer. I'm purposely using the same problem so that you know exactly what it is that we're finding with synthetic substitution. Now we're going to do synthetic substitution. And I know somebody is thinking to raise their hand and ask me if I was there. Hey, on the test or quiz, do we have to do synthetic substitution or direct? Well, when I ask you for a specific method, you have to do it by that method. Otherwise, you cannot get full credit. Okay? All right. So if we want to do synthetic substitution, we have to create a synthetic division chart. Put in the coefficients here. So x squared, x to the 1, and x to the 0. So 2, 9, -35. Out here, it's actually a little bit simpler. There is no work involved. You just put that number 2. So now the first comes down. Multiply by the outside number, you get 4. You add, you get 13. Multiply, 26. You add, you get -9. And hey, that answer that we had said was the remainder is actually f of 2. Okay, somebody's saying, well, why do I have to do this if I could just do direct substitution? And the answer is, if you have to do f of 3 over 2, so instead of the red 2, if you had a 3 over 2, and if it was, raised to the power of 7 and 9 and 5, the synthetic way is going to be so much simpler, okay? That's the reason. Okay, now let's do f of -7. Same deal. 2, 9, -35. Outside, I'm going to put -7. Okay, that number. 2 comes down. Multiply by the outside number, I get -14. I add here, 9 minus 14 is -5. Multiply by the outside number, I get +35. And when I add, I get 0 for the remainder. So, oh my God, f of -7 is equal to 0. Whoa. Okay, so now the question is, okay, before we were asked, are any of these zeros? We already gave that away. We know that -7 is a 0. How can you tell that any of these are zeros, right? How can we tell? Well, we can tell because when you do synthetic division, the remainder is 0. Okay. All right, so we're almost there. A polynomial function of degree n can have, at most, n real zeros. Okay, what the heck does that mean? Okay, first of all, what is this thing called a degree? Okay, this has nothing to do with going to college and getting a diploma, all right? A degree of a polynomial function is just the highest exponent in that polynomial function. So, I don't know what that says. No, I don't want to add a device. Okay, so whatever the degree of a function is, so whatever the highest exponent of a polynomial is, it has that many zeros. Meaning, if it's, something like this, the highest exponent is 2, it can have at most 2 zeros, okay? So look at this one. I have 3x squared. This can have at most 2 zeros. Look at this one here, x squared. It could have at most 2 zeros. Now, somebody was nice enough to actually find the zeros of these functions, okay? In the first polynomial, I got 2 zeros, -3 and 2 over 3. Now, these are both what we call rational functions. That means they're either whole numbers or they can be written in terms of a fraction, which is either a repeating decimal or it ends. Okay, look at this next one. Somebody found the zeros to be plus or minus √5. √5, this is a non-ending decimal. It's an irrational number. Okay, why am I talking about this? Because suppose you have a function and it's x to the 5 minus x squared plus x minus 3. The highest exponent here is a 5. This means this can have 5 zeros at most. Now, there are a couple things you can do to find those zeros. One thing is, think about how many numbers are in the world. Infinite. You can sit and you can plug in every single number you can think of until you find the 5 that give you zeros, right? Okay, plug in 1, 2, 3, -1, -2, -3. But then you also have to do like 1 over 2, 1 over 3, 3 over 7, 4 over 7. I mean, there is an infinite possibility. There are infinite possibilities, right? That's one thing you can do. Or there is this theorem that gives us an A-list of values, right? So that if there were any rational zeros to this function, it would be from that list, okay? So the last thing we're going to do today is just come up with that list for a polynomial, okay? And then we're going to investigate more next time. So here's the rational zero theorem. Don't let the fact that it's a full page scare you. It's really not that scary. Okay. Look at this polynomial function, 2x cubed, blah, 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 blah. Highest exponent is a 3. So there are at most 3 zeros of this function. Okay. That term with the highest exponent has a coefficient. In this case, the coefficient is a 2. We're going to use that number 2 to find some specific values. And then something else that we're going to look at is the constant term with no variables. That's this one. That's a 4. So the only thing we're going to use from this polynomial is the 2 in the blue and the 4 in the red. Okay? We're going to use that red 4 to find these values which we call P. We're going to use the blue 2 to find these values which we call Q. Okay, what is P? P are all the factors of the term 4. Okay, what are the factors of 4? What two numbers do you multiply to get 4? Okay, 1 and 4, 2 and 2, but also -1 and -4, and -2 and -2, right? So the factors are plus or minus 1, plus or minus 2, plus or minus 4. Okay, in short, I'm going to let you abbreviate and do plus or minus 1, 2, 4. Okay, to find the values of Q, You probably guessed it already. It's all of the factors of the other coefficient 2. How do you get 2? You can multiply 1 times 2, or -1 times -2. So the factors of q are plus or minus 1, plus or minus 2. So you can abbreviate by writing plus or minus 1 and 2. Now what we want to do is divide each of the values of p by each of the values of q. So, where is p? Okay, let's do this one by one. I take 1 and I have to divide by each of the q's. So I do 1 over 1, 1 over 2. Now I'm done with that. I take the next number in the p's, 2. 2 over 1, 2 over 2. Yes, we're going to simplify these in a minute. Then I take the next number in the p's, 4. 4 over 1, 4 over 2. All right? It's like if you have a team of 3 here, and if you have a team of 2 here, and everybody in P's team has to play one match against everybody in Q's team, right? So you have to do all the possible matchings. Okay, now we're going to simplify this. So we have to put in the plus or minus. And now what do we have? 1 over 1, that's 1. 1 over 2, that's 1/2. 2 over 1, that's 2. 2 over 2, that's 1, but I already wrote a 1. I don't need to repeat, so I move on to the next one. 4 over 1 is 4. 4 over 2 is 2. I already have a 2, so I'm done. And that is a list, okay? And this is a list of all possible rational zeros of the function f of x. That means, remember how we said you can sit and you can try every single number in the world to see if it's going to be a 0 of that polynomial? Well, now I've reduced it to a very small list so that the only possible values that could be zeros of this function are in this list. Let's count how many numbers are in this list. 1, 2, 3, 4, but also they're negatives, so total 8, right? There are 8 numbers. So for example, does the number 3 appear in this list? No. So 3 can never be a 0 of this polynomial. -7 can never be a 0 of that polynomial. Can 1/2 be a 0 of that polynomial? Yep, that's right here, so it can. Okay, so that's what we've done. So on your homework, you're going to have to list the possible rational zeros. That's what that is. All right, guys, thank you so much. I look forward to seeing you guys next time. Please pick up a handout and do that handout for homework for next time. Have a good day, everybody.